Modern data systems are modular. We separate responsibilities into specialized components. So one component will handle loading the data, another will handle transformation, another will handle orchestration, and so on. There's only so much complexity you can keep in your head at once. So separating into these components allows you to work on one thing at a time rather than worrying about breaking something else when you are changing one section of the system. It also lets us take advantage of specialized tools. So I could write a Python script to load data from Shopify into BigQuery, but Airbyte has a whole team maintaining this functionality. They've already handled things like retries, incremental syncs, they'll automatically handle API changes for us. Their ingestion code is almost certainly going to be more robust than something that you or I would write. Here's an overview of what we're going to build. We'll use Airbyte to extract the raw data from Shopify and load it into BigQuery. And then we'll use dbt to transform that data into business-ready data sets. You'll also notice that Airbyte extracts and loads the data before dbt is used to transform this. This contrasts with traditional ETL data pipelines where data was transformed before being stored in the data warehouse. Storage is cheap, and by extracting and loading the raw data, it keeps that step in the process simple. This preserves the original data and makes the pipelines easier to maintain, update, and debug. It also lets us build transformations without re-ingesting the data, which speeds up the development process. Okay, let's get to building. So in this section, we're going to build the Google Cloud infrastructure needed to host the project, and we're going to focus on two important concepts: infrastructure as code and principle of least privilege. First, infrastructure as code. So this means defining your code in a script or something like Terraform rather than manually configuring in the GUI. There are quite a few benefits to this. First, it's repeatable. Second, it's version controlled. And third, it eliminates any manual errors when clicking around the GUI. The second concept is principle of least privilege. So each element has its own identity and only the permissions it needs to perform the job that it should do. So the Airbyte service account would have permission to write to the raw data set, but it would not be able to touch the analytics data set. dbt would have permission to read from the raw data set and write to the analytics data set, but it could not modify the raw source data. Separating these identities limits what can go wrong if one of them is compromised or misconfigured in any way. All right, let's get into the code to build the infrastructure. I'm just going to walk through this script I wrote. So first we set the GCP project ID, the location, and the names of the service accounts that we're creating. We have a separate one for Airbyte and one for dbt. Then we set the project to make sure that we're on the correct project. We enable the APIs that we'll need. So for this project, we just need BigQuery and IAM. And then we're going to create the two data sets for this project. So we have raw, which will hold the raw data from Shopify that's ingested from Shopify into BigQuery. And then we'll have an analytics data set, which holds the dbt transformations. That'll take just a second. And then we're going to create the service accounts. So like I said, we'll have one for Airbyte and one for dbt. So we'll create these. And then separately, we grant permissions to these service accounts. So for Airbyte, we're having BigQuery user. For dbt, we're having BigQuery job user. So the difference is job user allows the principal to create jobs. User allows jobs and a few other project level capabilities that Airbyte needs. Cool, those were created separately. And then here's where another application of principle of least privilege. So we created a script to give the service accounts the specific data set level permissions that we need. So I'm going to open up this grant permissions. And here you can see, let me pull this down a little bit. Here you can see to the raw schema, the Airbyte service account is given data editor because Airbyte has to be able to update that raw data. And then for the dbt service account, that needs to be able to view data in the raw schema and edit data in the analytics schema. So you notice our Airbyte service account can't touch the analytics schema at all. So we'll run this to grant those permissions. Oops. Okay, I'm already in the scripts folder, so we'll just run. We'll just run this. Okay, great. Those permissions were properly granted. And then finally, we want to store the service account keys locally. So the service account credential keys, the JSON credential files, are generally stored outside of the project directory. I store them here in my home directory in config.gcp. We'll create that directory if it doesn't exist. And then we're going to write the 2 service account files to that folder. That way we have them locally and we will reference them in future steps in the project. And that's it. We now have our GCP project set up. We'll start with ingesting that raw data from Shopify and moving it into BigQuery using Airbyte. This is the extract and load step of the ELT pipeline. This step, along with literally every step in the ELT pipeline, has turned into an industry of its own. Extract and load is now an industry that has raised literally tens of billions of dollars. Here's just a small list of the competitors in the space. And all of these competitors are simply handling, I say simply, but it is a pretty complex process, handling syncing your data with source systems. They just move from source data to raw data. And for this data, it handles the ongoing synchronization. What used to be a complex problem of deciding what data to update, when to update it, and how to avoid duplicate records has now been essentially a solved problem. You just click the connectors you want and the fields you want to bring in, click sync, and Airbyte handles the rest. Now I'm going to show you how this actually works and how you can get Airbyte set up for your project. Okay, so let's get started running Airbyte. I'm just going to walk through these quick start instructions. So first, install Docker Desktop. You'll need to install Docker Desktop and have Docker running while you walk through these. And then you'll need to install abctctl. This is the Airbyte command line interface. I've already done both these steps, so I'm going to skip through it. And then each time we want to run Airbyte, we run this abctl local install. So this can take up to 10 to 20 minutes the first time you run it, but in subsequent runs it takes just 1 or 2 minutes. And I'll fast forward through this. Okay, so we have Airbyte installed and it's up and running, and now we'll go back to the instructions. All right, now we want to set up authentication. So I'm going to run this credentials command, which will get the credentials for the local project. All right, so the email, we have a password. So I'm going to go here, enter this password. All right, now we're all logged in. That's it for the setup. Okay, so let's get to building the connection. So Airbyte has connections, which are sources and destinations, and then you can also see the list of available sources and the list of available destinations. But we'll just start from here. So we'll create our first connection and our source. We'll set up a new source, and we'll use Shopify, and then we're going to do API password authentication. You can do whatever authentication you want. I'll put in the shop name there, and then the API password. And we'll just leave the source name as Shopify. Now it's validating that connection. Okay, cool. So the connection was validated. Now we select our destination, which is BigQuery, and we got to fill in these fields. So project ID is it ETL example mat? That's your project ID from BigQuery. So ETL. Dataset location, this is important that it matches your dataset location in BigQuery. If you remember, we selected USA, and then raw. So this is where the schema the dataset that the Shopify data will be extracted and loaded into. And then our service account key, if you remember, we created this earlier in our home directory, and I'm just gonna pull up how I get to it. All right, so we go to our home directory. And this is where I stored it. Remember, your credentials could be stored anywhere, but this is where I stored it. And I'm just going to grab this whole thing, this whole JSON blob, and paste it in here. And now it's validating the connection. Okay, great. So we got our source, we have our destination, and now we just need to select the tables we want. In this case, we're just going to use orders, but yeah, you can select any tables you're interested in and any fields you're interested in here. But we'll just do orders for now for this example. And then here we get to select when we want it to refresh, whether it's manual, scheduled, or through cron, how often our data will sync with the destination. That's pretty much it. And now it's syncing. So this will take a few minutes. Okay, it looks like the orders table synced successfully. So now we have our extract and load portions of the data pipeline complete. And for most production projects, configuring through the GUI is more than sufficient. Okay, now that Airbyte has loaded our raw data into BigQuery, we need to transform it into business-ready data sets. This is where dbt comes in. At its core, dbt is just a way to organize SQL. But really it brings software engineering best practices to managing your SQL transformations. Instead of having a collection of SQL scripts that needs to be managed manually, dbt organizes transformations into models and manages the dependencies between them. So really, it lets you define automated data quality tests, it keeps your transformation code in version control, and it automatically generates documentation. One of my favorite parts of it is the lineage graph, which we'll show when we get into the documentation in more detail. And dbt isn't actually a database. All of your data stays in BigQuery. dbt simply defines how the transformations turn the raw data into clean, business-ready analytical models. Okay, let's get started with this dbt project. So we'll create a new directory. We'll just call it ETL proj. CD into that directory and open it in VS Code. Okay, so similar to any project, make this a bit bigger. We're going to create a virtual environment. This is so that our code for this project is isolated from the rest of our computer. I'll fast forward through this, but I'm going to create a virtual environment, activate it, and install dbt BigQuery, which is a pip package. Okay, it looked like everything installed successfully. The other thing I like to do, and this can avoid some pain down the line, is make sure that we're connected to the correct dbt project. So you can see here, the dbt that we're connected to is the one from the virtual environment we just created. Now we'll run dbt init to get this started and scaffold the project. So name, example, and then the database we want is BigQuery. We'll use a service account, the one that we created earlier, as authentication, and I'm going to copy that path into here. So this is the path wherever your service or wherever the credentials file lives. This was ETL example mat, our GCP project ID, dataset name. This is analytics. This is where our dbt transformations will live. Threads 4 is a good default, and job execution timeout 300 seconds is fine. We'll select US here. It's important that this matches the location you selected in the rest of the project. So what we're doing here, answering all these questions, this is creating an entry in profiles.yaml. And so if you want to change any of these parameters after, you can go into the profiles.yaml and manually update them, but running through these questions creates that entry for this project automatically. Okay, great. Now the project is set up. We can go in here and we can see the project and all the folders that have been created. So this was the scaffold that was created with dbt init. Before we get started building models, I want to install dbt utils. This is a very common package to use on dbt projects. So to add this, we'll add a packages.yaml file. I'm just going to copy some code in from over here. But similar to Python libraries, dbt supports libraries, and dbt utils is a common one used in almost every single dbt project. We'll give a few examples later on in how it's used, but I would recommend using it, installing it on your dbt project. So we add it to packages.yaml there, and then we install it by running dbt deps. Oops, it looks like we weren't actually in the dbt project, so we have to cd into ETL example. Then if we reinstall it, it should work. Yep, dbt utils is now installed. Alright, now I want to give a quick overview of profiles.yaml. This defines how your dbt project connects to your data warehouse. And so these definitions live outside of the project, and they allow you to specify different dev, test, and prod connections without actually changing the code within your project. So the profiles project lives outside of your project directory. On a Mac, the standard place is in .dbt profiles.yaml in your home directory. Have in mind, you can see how you specify dev, prod, and any other environments that you have. Let me scroll down to the one we just created. I think it was ETL example, and you can see it defaults to the dev environment. The data set was analytics. This is the path to our key finder. These were all the questions that we answered. As this project grew and we had a test and prod environment, we would add new entries to profiles.yaml here. Okay, now we'll discuss dbtproject.yaml. So this file specifies metadata for your project name and the version of your project, which profile it's looking at. So in this case, it's that ETL example that we just looked at in the last section. It specifies the path to each folder. So, the defaults are built when you run dbt init, but you can modify that based on your project needs. Clean targets. So these are folders that are rebuilt each time you run dbt build. And then finally models. So here's where we specify the configuration of our models. So in our case, we're going to have staging, which we will materialize as a view, and we'll have marts, which will materialize as a table. And we'll discuss this in more detail in the next section. Next, we're going to specify the sources for our project. So this is where the raw data is coming from. And we'll specify that in a sources.yaml file. We're going to set up our models first. We'll have staging, have marts, and then in staging, we're going to add our sources.yaml. And this follows the kind of the standard dbt naming convention. Create this file. And so the name is the data set we're looking at. So as we know, our raw data set is our source here and our only source on this project. The table we want is orders, because we're only having one source table. So that's it. In this sources file, you can also add data validation tests. We're not going to do it in this example project, but it would be a good idea in your production projects. Okay, I want to give a quick overview of the dbt project structure. So we'll start from the top, analysis. This is where you would put ad hoc SQL scripts. So anything when you're validating data or testing new functionality could go in analysis. dbt packages, this would be part of the git ignore. This is where the actual packages live that you're using. So you see dbt utils is currently the only one we have installed. Macros are where you put any reusable functionality. Models, this is where all of your data transformations live. In this case, we have our staging models and we have our marts models. In a production project, you may also have intermediate models, but we'll keep it simple. Seeds are any seed data you need in the project. Lookup tables are a good example of data that would go in seeds, or really any reference data that all users would need for your project. Snapshots hold historical records of your data. Tests are for data validation. We'll discuss this in detail in a future segment. Data models are where we transform that raw data into useful business-ready data sets. This is really the core of a dbt project. So in this example, if you remember, we were just using orders as our source data. And from orders, we're going to create two staging models. We'll create orders, which is almost a direct one-to-one copy of the raw Shopify orders data. Remember, generally in staging, the data will be pretty close to the raw data with just a few renames, some deduplication, really minimal transformations here. And then we'll create line items. And line items currently lives as a JSON field within the orders table on Shopify, but we want it to be relational because that makes it a lot easier for us to run analytical queries on it. In this project, we're going to follow the best practices specified by DBT. I'll link to the DBT docs below. You can also just Google them. But following their best practices is generally a good idea unless you have a good reason not to. Now we'll get into building the staging models. We'll start with staging orders. So naming convention is commonly staging underscore table name .SQL. And then here we're going to pull in the source data, and then we're going to select just the fields we want and do a few transformations. If you remember earlier, we installed the DBT utils package. We'll show you one example of how we can use it. And then, so we'll call dbt utils.deduplicate, brackets around it. And so DBT utils offers a bunch of reusable macros that we can call throughout the project. And so this one will just deduplicate based on selected relation. And so source is how we call any data sets that we specified in our sources file. These are data sets that live outside of the DBT project. And here we're looking at raw.orders. This is the field we're deduplicating on. And then we're going to order by Airbyte internal field and descending. So we want the most up-to-date record from the Airbyte dataset. And then now we're just going to select the fields that we need. So we'll do, that's fine, ID. We want customer ID, and so that comes from a JSON field. And I'll show you this in just a second. I'll type this out first. So from our customer JSON, we want as customer ID. And actually, since this is an ID field in the JSON, we want to cast it to an integer. So we'll cast this as int64, close this, and then get customer ID. I'll quick show you where this comes from. Alright, so if you see in our, let me see here in our orders table, we have this customer JSON, and we are just grabbing the ID field from here. Alright, and then we'll just pull in a few more fields, total price, order number, and all these fields come from the raw data. We'll show one rename, so we'll rename created at as order date, and we'll pull in financial status. And this is all coming from deduplicated, which we defined above here. Save that, and then we'll run dbt build to make sure everything is working correctly. Cool, completed successfully. So now if we go into BigQuery, we can see we have this staging orders table with just the fields that we specified. Next we'll show, so I like to, for each of my SQL files, I like to have a YAML file. This isn't the only way to do it. YAML files can be used to specify more than one SQL file, but this is a way to keep your project pretty well organized. So for this one, so this is associated with staging orders, add a description, staging models for the orders table, and then you can specify the columns here and their associated descriptions. I'll just keep it real simple, we'll just do one. And then this is the primary key. Primary key. So in this file you can also specify data tests, but we'll do that within the testing section, which will be the next segment of this video. So when building the staging models, we generally want to keep the transformations relatively limited, keeping the staging models similar to the raw data. Keeping the staging model similar to the raw data is generally best practice. So within the staging models, we do things like rename columns, deduplication, as you can see there, very light transformations, and then the staging models are generally materialized as views because they're inexpensive to run those transformations. All right, now we're going to create staging line items. So often we're going to take the JSON in the line items from the raw orders table and transform it into a relational table. So similar to customer, let's see if we can find it. Line items is a JSON array, and so we want to take all of this data out and create its own line items table because it's easier to work with relational data. It would be hard to parse out and aggregate over this JSON. All right, and I'm not going to discuss in detail the line items table and what we need to put in there. It's a little bit outside of the scope of this project, but I'm going to copy and paste some code into here. I can briefly discuss, but I won't type it all out. So we're selecting from raw orders, so the same source data. And then we are creating this new table that has order ID. Similar to what we did with customers, we're pulling out the JSON values for line items. And then we are running a cross join, which pulls them all out and creates a new table with the order ID. I'm going to save this, and dbt.build again. Great. We'll get into building the MARTS models now. So these are the business-ready data sets that will be used by your analysts, business users, and reports and dashboards. Generally, these are materialized as tables because these are more expensive transformations and calculations and aggregations that we wouldn't want to run each time a dashboard needs data. We want to run it once and then share that aggregate data with the dashboard to limit the number of times that we run those expensive transformations. All right, so I'm going to create orders.yaml or orders.sql. And I'm just going to copy some data into here and then I'll explain it. Okay, so we're getting data from staging.orders, and ref is a key concept in DBT. You use ref when you're referencing data sets built by DBT transformations. Ref makes it really easy to rename files. It allows for environment independence. You don't need to hard code the table name, you're just hard coding this reference field, and then you can use that throughout dev, prod, and testing environments rather than hard coding names for each environment. It also helps with validation because if a reference is missing or invalid, it will fail during the DBT build stage rather than failing silently in production. All right, so we're pulling in, we're referencing orders, we're referencing that line item staging table we just created, and then we're going to create some aggregate fields here. So we're counting the line item count per order, listing products, quantity, and revenue. And then in our final data set, so we're just pulling in the fields we need from both the orders table and that new line item by order table, and then we're joining the line item by order table. So I'm going to run dbt build here. Okay, we have an error, so let's get into this. All right, it looks like we just have a incorrect name here. It's stage order line items versus stage orders line items. So I'm just going to search for that, and this should be orders. Try again. Cool, and that completed successfully. We can go into the cloud environment and see that once again that this table was built. So BigQuery, we'll refresh this. Oop. And now we got our orders. We have staging orders line item, and we have our orders table with just the fields that we specified for the business users. Okay, and now I want to create the YAML file for the orders table. So to me, this is the most important YAML file. So this is important both for humans as well as if you want to use AI on your data or for AI agentic data analysis. The YAML file in your business-ready data sets is very important in specifying what each KPI means so that the definitions are uniform across your business. What revenue means, what cost means, what all those KPIs mean. You want a shared definition so one business unit isn't thinking about that KPI in a different way than another one. And I'm just I'll copy some data in here and then I'll talk about it a little bit. So I mentioned we'll discuss tests in the future section, but we just put in descriptions of the table and then descriptions of all the fields. And this is the same, but it's important that you really spend time making sure that these definitions are clear and correct. In this section, we're going to get into testing and validation. So we'll add standard tests, we'll add generic tests, which can be reused across tables, and we'll add custom one-off tests that are generally cross-table tests. So let's get started. First, for the standard tests, we're going to go to staging.orders and add a couple here. So you can call this data tests, or you can call it just tests. So this is a primary key, so we want it to be not null and unique, so pretty simple. And then we're going to add an accepted values test. Let me make this a little bigger. So we'll go name, we'll do it on the financial status field. And we want data test accepted values. So we're saying that it can be any of these accepted values. I'm going to save this and let's run it now. dbt, that's in Claude. dbt test. Okay, it looks like our accepted values test failed, so we'll figure out why that was the case. This one is relatively straightforward to check out. So we're going to go into staging orders. We're going to query this. I'm going to select distinct financial status. All right, I see paid, refunded, partially refunded. And in this, it looks like we're missing partially, so we're going to add that in here. Rerun. Okay, and all our tests completed successfully. Next, I'm going to show you how to add a custom one-off test that bridges two tables. This test is going to demonstrate that the line items table has a valid order. And I'm just going to copy some code into here. So we'll create a new test. Line items have valid order. That's equal. And we'll copy this into here. So here we're referencing the staging orders line items, we're joining orders, and we're ensuring that the line item order ID matches the order. It should be order.id. Okay, and then we'll run the test. Okay, great. All of our line items have a valid order. And finally, I'm going to show you how to add a generic test. So I like to put these in a generic folder. And then we'll create a new script, and we'll call this not in future. So this will just validate that a date field is not in the future. So we'll write this one out. It's pretty simple. Test, so this is important. This is specifying that it's a test and not just a standard macro. I want both the model and the column name. And these will be pulled in directly by dbt. And then we want from model so this is where column name is not greater than current date. And I'm actually going to use current timestamp because that's the format of my data. And then to use this test, we'll go into the orders.yaml, an order date, and then we can add a data test here. We want it to be not null, and yeah, got it. We want it to be not in the future. We run this. Okay, great. It all completed successfully. So those are just a few examples of how you can do testing and validation in dbt. dbt has a very powerful validation framework, and I encourage you to utilize it to its fullest on your project. One of dbt's most powerful features is that the documentation lives directly alongside code. I've showed you how in development you can write the documentation along with the code. Now I'm going to show you what features that actually enables within the dbt environment. So we'll run dbt docs generate, which generates our documentation. And those are just some harmless warnings. Then we'll run dbt docs serve. All right, so here's what we get. We get this documentation GUI that your whole organization can have access to. So it shows all of our data sources, how large they are, all the columns in them, any descriptions that we've added, any data tests that we've added, any constraints. It shows all this metadata on our data sets. And then we can go into our specific projects and we can see the transformations that we've created. Once again, how large they are, all of the different columns, even the SQL that is used to generate these tables. But my favorite part of this is the lineage graph. So we can go in here and we can see where our data comes from and the entire process. So this lineage graph is obviously pretty simple because our project is simple, but as your projects grow, this can be a great help in tracing down data issues, data quality issues. So in our case, we're just going from raw to staging to orders, and then this is a validation that test that is run. So it's pretty simple, but as you can imagine, in a more complex project, this can be a very powerful feature. Okay, that's it. We now have a complete data pipeline with BigQuery, dbt, and Airbyte. Please let me know in the comments if anything is confusing, and like and subscribe if you'd like to see similar content.